Welcome to section 7.3. Today we're going to be discussing power functions and functions operations. So today we're going to learn how to do adding, subtracting, multiplying, and dividing of functions, and then we will learn how to do something called composition of functions in this section. So these are the four basic operations that we're going to be working on with functions. We'll learn how to add, subtract, multiply, and divide functions. So whenever you see this new function being defined here, it basically just means for addition, it means you're just adding the first function and the second one. Then so on and so forth. For subtraction, you're subtracting these two, multiplying, you're multiplying those two, and dividing, you're dividing those two. This is how we just show them symbolically. So for example, if I'm adding two functions and I'm saying that f of x is 2x to the 1/2 and g of x is negative 6x to the 1/2, all we do is we add those two together. Now we can add these two together because they both have the same base and their exponents both have identical indexes. So the answer for this one would just be negative 4x to the 1/2. For subtraction, very similar. If we want to figure out what this new function h of x is going to be, if we're subtracting, all we do is just subtract the functions. And once again, these have like radicals, so we can subtract them. So it's a negative 6x, but since it's subtraction, that will be a negative and a negative, so it'll be a positive. So I have 8x to the 1/2. Multiplying, you multiply the same way that you would in any other situation. So we're trying to figure out what our h of x is. All we do is do 3x times x to the 1/4. Now we know when we're multiplying similar bases raised to different exponents, we have to add them. So it's going to be 3x to the, and I'm just making this 4/4 so we have similar denominators. So this will be 3x to the 5/4. And division, same thing. If we're going to be dividing these two, we line them up. And since x and x have similar bases, we know we can subtract those exponent values. So it's really 3x to the 4/4 minus 1/4. And we do that, we have 3x to the 3/4. Okay, so those are the four examples of addition, subtraction, multiplication, and dividing of functions. Okay, so now let's get to the second part of this section, and that's composition of functions. So in composition of function, what we're doing is, instead of plugging in numbers for x values in our functions, we're plugging in entire functions. So normally what you would have is something like this. You'd have f of x equals 4x. And then I would say, okay, well, evaluate that when x equals 2. So when the function was being evaluated at 2, all you would do is just plug in for that x. So now the only difference is, instead of this being an x value, it's going to be a function like g of x equals x squared. And we'll do examples of these. So this is compositions of functions. Okay, so for our first example, we're going to have our f of x equals 3x to the negative 1, and our g of x equals 2x minus 1. So like I said, the way we write this is f of g of x. So the way we say that is f of g of x. So let's make sure we're saying that correctly in class. So what I'm doing here, normally what I would do is I would just plug in the x value right here. But now I have to plug in an entire function. So what that looks like is I'm plugging in f of 2x minus 1. So what I'm doing here is, instead of plugging in a number right here, I'm plugging in an entire function. So my f of g of x is going to look something like this. I'm plugging in this 2x minus 1 into the x of the original f of x function. So it's 3 times 2x minus 1 raised to the -1. Then I need to incorporate the negative exponent, so what I do is it's 3 over 2x minus 1. Okay, so that's how we figure out what the composition of function would be. One thing we're going to have to start doing is finding the domains. Now we know from previous sections the domain is just the input values. So it's what you can put into the function. Or usually for us it's going to be the x values. So I won't do it on this example, but on the next example we're going to find the domain of the new function as well, because I don't have enough space here. In this example we're going to be doing composition of functions to figure out what g of f of x is. So I know what g of f of x is. So once again we're plugging in entire functions for our x values. So in the function g we're going to be plugging in 3x to the -1. So our g of f of x function is, we're going to have the 2, but instead of the x we're going to have 3x to the -1 minus 1. Now when we simplify this we're going to have 2 times 3 over x minus 1. This 2 and this 3 will combine here, so it'll be 6 over x minus 1. Now in this function we want to figure out what the domain is. So like I said, the domain is the input values. But we need to figure out which input values work for f of x and g of x. When we look at both of these functions, the x value that doesn't work is all real numbers work. So this is an abbreviation for all real numbers. All real numbers work except x cannot equal 0. So this is the domain of this function. All real numbers, but x cannot equal 0. So why can x not equal 0? Well, in our function 3x of negative 3 times x is raised to -1, that's effectively written like this as well. And we can't have a 0 in the denominator. So this doesn't work for f of x, so it can't work for the composition of both functions. In this example we're going to do f of x. So be able to say that correctly. So what we're doing is we're plugging in this entire function back into the x position. So we're evaluating this function when x equals 3x to the -1 is what we're essentially doing. So we set up our function and we have 3. Now instead of an x here we're going to write 3x to -1, and that also is raised to the -1. Just remember, all we're doing is plugging in entire functions in for x. So we have to do order operations. We have to deal with the exponent first. So I distribute this through. I have 3 to the -1. Then I have x times x to the -1 raised to -1. So those are just going to be multiplied. That ends up just being x. So what I have is 3 times x over 3. These are going to cancel out, and I end up with x. Now the domain here, remember, it's the input values. What values work here? And it really is any values. So for here, we say all, and I'll abbreviate this, and this is the way you'll see me abbreviate this here, all real numbers. Okay? Because any x value, any number here works for this function, which is just x. Okay, so we have 2 more practice ones that I want you to work on. So I want you to pause the video now, work on them, and then also when you try to do this, try to figure out what the domain is for each of these. Okay? So pause the video now, work on these, and then on the next slide we'll go over the answers. Okay, so for the first one of f of g of x, you are evaluating the function when x is x minus 1. So what we end up with is 2 over x minus 1. So the domain, I'll write a up here. The domain for this one, try to figure out which x values work here. So you know for this one, x can't be 1. Because if x is 1, then you have 2 over 1 minus 2, which would be 2 over 0, and that's undefined. So the domain for this is all real numbers, but x cannot equal 1. Okay, for b, you should have got 2 over x minus 1, and our domain is what are the input values we can have for x. Well, x just can't be 0. Any other value works here. Okay? Alright, we're going to end there. Once again, thank you very much, and I will see you on the next video. Thank you.